What is a block and block scanner in HDFS? Block, the minimum amount of data that can be read or written, is generally referred to as a block in HDFS. The default size of a block in HDFS is 64 megabytes. Block scanner. Block scanner tracks the list of blocks present on a data node and verifies them to find any kind of checksum errors. Block scanners use a throttling mechanism to reserve disk bandwidth on the data node. What is commodity hardware? The commodity hardware is a non-expensive system which is not of high quality or high availability. The Hadoop can be installed in any average commodity hardware. We don't need supercomputers or high-end hardware to work on Hadoop. Yes, commodity hardware includes RAM because there will be some services which will be running on RAM. What is the port number for name node, task tracker and job tracker? The port number for name node is 70, for job tracker is 30 and for task tracker is 60. Explain the difference between name node, backup node, and checkpoint name node. Name node. The name node stores the metadata of the HDFS. The state of HDFS is stored in a file called fsimage and is the base of the metadata. During the runtime, modifications are just written to a log file called edits. On the next startup of the name node, the state is read from fsimage, the changes from edits are applied to that and the new state is written back to fsimage. After this, edits is cleared and contains is now ready for new log entries. Checkpoint node. A checkpoint node was introduced to solve the drawbacks of the name node. The changes are just written to edits and not merged to fsimage during the runtime. If the name node runs for a while, edits gets huge and the next startup will take even longer because more changes have to be applied to the state to determine the last state of the metadata. The checkpoint node fetches periodically fsimage and edits from the name node and merges them. The resulting state is called checkpoint. After this is uploads the result to the name node. There was also a similar type of node called secondary node, but it doesn't have the upload to name node feature. So the name node need to fetch the state from the secondary name node. It also was confusing because the name suggests that the secondary name node takes the request if the name node fails, which isn't the case. Backup node. The backup node provides the same functionality as the checkpoint node, but is synchronized with the name node. It doesn't need to fetch the changes periodically because it receives a stream of file system edits from the name node. It holds the current state in memory and just need to save this to an image file to create a new checkpoint. Explain about the process of intercluster data copying. HDFS provides a distributed data copying facility through the DistCP from source to destination. If this data copying is within the Hadoop cluster, then it is referred to as intercluster data copying. DistCP requires both source and destination to have a compatible or same version of Hadoop. How can you overwrite the replication factors in HDFS? The replication factor in HDFS can be modified or overwritten in two ways. One, using the Hadoop FS shell. Replication factor can be changed per file basis using the below command $hadoop fs set rep w2/my/test_file. Test_file is the file name whose replication factor will be set to 2. 2. Using the Hadoop FS shell, replication factor of all files under a given directory can be modified using the below command. $3 Hadoop FS set rep w5/my/test_dir. Test_dir is the name of the directory and all the files in this directory will have a replication factor set to 5. Explain the difference between NAS and HDFS. NAS runs on a single machine and thus there is no probability of data redundancy, whereas HDFS runs on a cluster of different machines, thus there is data redundancy because of the replication protocol. NAS stores data on a dedicated hardware, whereas in HDFS all the data blocks are distributed across local drives of the machines. In NAS, data is stored independent of the computation and hence Hadoop MapReduce cannot be used for processing, whereas HDFS works with Hadoop MapReduce as the computations in HDFS are moved to data. Explain what happens if during the put operation, HDFS block is assigned a replication factor 1 instead of the default value 3. Replication factor is a property of HDFS that can be set accordingly for the entire cluster to adjust the number of times the blocks are to be replicated to ensure high data availability. For every block that is stored in HDFS, the cluster will have N1 duplicated blocks. So, if the replication factor during the put operation is set to 1 instead of the default value 3, then it will have a single copy of data. Under these circumstances, when the replication factor is set to 1, if the data node crashes under any circumstances, then only single copy of the data would be lost. What is the process to change the files at arbitrary locations in HDFS? HDFS is a massively large block distributed file system where the block size is minimum 64 megabytes, 128 megabytes. You cannot change content of a file stored in HDFS at arbitrary location. When the need arises to do so frequently, you should consider storing file content as rows in NoSQL. For example, Base will allow you to modify the content of the row at arbitrary locations. These modifications are gathered in memtable in memory and then to SS table, which are stored as file with skiplist index to locate the row in the file. This file is stored in HDFS, but now you can access random locations using the skiplist index in file. Also, you can modify a row at random location, which will gather changes in memory and later flush to HDFS using SS table/file. Explain about the indexing process in HDFS. Indexing process in HDFS depends on the block size. HDFS stores the last part of the data that further points to the address where the next part of data chunk is stored. What is a rack awareness and on what basis is data stored in a rack? All the data nodes put together form a storage area that is the physical location of the data nodes is referred to as rack in HDFS. The rack information, that is the rack ID of each data node, is acquired by the name node. The process of selecting closer data nodes depending on the rack information is known as rack awareness. The contents present in the file are divided into data block as soon as the client is ready to load the file into the Hadoop cluster. After consulting with the name node, client allocates 3 data nodes for each data block. For each data block, there exists 2 copies in one rack and the third copy is present in another rack. This is generally referred to as the replica placement policy. What happens to a name node that has no data? There does not exist any name node without data. It cannot be part of the Hadoop cluster. If it is a name node, then it should have some sort of data in it. It cannot be part of the Hadoop cluster. What happens when a user submits a Hadoop job when the name node is down? Does the job get into hold or does it fail? When name node is down, your cluster is off. This is because name node is the single point of failure in HDFS. Whenever a client submits a Hadoop job, who receives it? Name node receives the Hadoop job, which then looks for the data requested by the client and provides the block information. Job tracker takes care of resource allocation of the Hadoop job to ensure timely completion.